Hey everyone, thanks for being here today. Hopefully some of you stayed up awake late enough to hear our magic and neuroscience talk last night. Thank you. The last time I was on the stage was 2014. I was here 2013 and 2014, so it's been a long time. And I am very excited to tell you about my vision and the work that I do on the next medicine for the mind. But first, I think it's appropriate to take a sort of hard view of today and why this is so important. So I've come to believe that we are in the midst of a crisis, and not just the external crisis that we inflicted upon our planet, but an internal crisis, a crisis of our minds, or what I call a cognition crisis. So when it comes to both understanding and enhancing cognition, we are tragically lacking. And I want to define this because I define it broadly. So our attention, our memory, our perception, our imagination and decision-making and reasoning, emotional regulation, empathy, compassion, and wisdom. And we are paying a great price for this. So we know over 500 million people on this planet are suffering the debilitating effects of impaired cognition. And it's getting worse, especially for our youth and our seniors. But this crisis extends beyond the clinical, right? And it touches all of us. So our limitations in long-term thinking, analytical, critical decision-making, and empathic concern are plain to see just by reading the news every single day. So I would say enhancing cognition needs to be placed on par with other pressing global priorities. Because if we can't focus our attention in a sustained manner and make wise and creative and future-oriented decisions that prioritize others over ourselves, we will never, ever be able to manage complex time-delayed crises like climate change, no matter how much information we acquire. So we really need to level up our minds. And I think that this message, which I've been giving for over a decade, is more relevant to today than any time that I've spoken in the past. Today, the paradigm is that there is a pill out there, a magic brain pill that is just going to cure our ailing minds. We haven't found it yet, but we will find it. Now, there's nothing conceptually wrong with the idea of a molecule to enhance cognition, but we've been on this pathway for like 80 years now, and we just have not targeted these molecules to the underlying computational unit of the brain, the neural network. And we have, done a lot of good with medicines for the mind, but just not enough. And we know that we have a decrease in death and suffering, infectious disease, cardiac disease, heart, and cancer, but the reverse trend is occurring for afflictions of the mind. Dementia, anxiety, depression, even suicide going the other direction. So we need a new paradigm and we need a new medicine. And what I want to talk to you today is how we might harness a core aspect of human neuroscience and development really as a new medicine, and that is experience. So for thousands of years, we humans have been creating and ritualizing experiences to enrich our lives. Music, art, dance, story, sports, and games. Right? We've also intentionally designed experiences that are positioned to support our mental health. So as we all know, the ancient and widespread practices of meditation and mindfulness are not just there for enlightenment, they're there to release us from the suffering of unhealthy states. And this is written in very ancient books about meditation, right? So stress, fear, grief, craving, and clinging. Despite this, and despite the vast literature on neuroscience showing that experience is a driving force of plasticity, our ability of our brains to change itself at every level, the structure, the chemistry, the function, the physiology of the brain constantly changing due to experience, most people do not think of experience as medicine in the same way they think about a pill, right? That's some really great marketing out there. And that can change and will change. And I know I'm sort of speaking to the choir here, but what I want to tell you about is how technology can help usher in that change. Now, again, I do not have to tell this audience that we are in an extraordinary time of technology. And before you even think about all these things on the screen, which you know about, just what we hold in our pockets, what we use every day are experience-inducing technologies. And their accessibility, the diversity, the power of them is just incredible. Now we have virtual reality, augmented reality, wearable physiological devices, motion capture, and AI. Now, most of this is positioned for entertainment, communication. We've heard some things about productivity. This is a meeting that's focusing on the sort of niche field that's emerging of health. But I would say that these experiences can have a profound impact on our minds and really usher in this future of experiential medicine, experiences medicine. But there's a very special type of experience that I want to focus on that I think holds the greatest promise, a targeted, personalized experience that I call the closed loop experience. So a closed loop experience is one in which the environment that you're being presented with is being updated in real time by your data. So to make this less abstract, here's a cartoon. Your brain, your body is interacting with a digital closed loop experience, and data is being collected about your state in the moment, your stress, your emotions, your performance, all feeding into a processor that's using algorithms to adjust the environment that you're exposed to on a tablet, or a phone, or a virtual reality, head-mounted display. The sensations, the challenges, and the rewards you're experiencing are personalized to you in that moment. So I want to point out here, it is the mechanics of these interactions that activate brain networks in a way that we have never accomplished with anything else before. No drug, no neurostimulation activates brain networks the way experiences do. And it is the closed nature, the adaptive aspects of this system that puts continuous pressure on those underlying brain networks to just harness your brain's inherent plasticity to optimize its performance. Like an ultimate personal trainer, collecting data multiple times a second, and then doing precision adjustments to your challenges and your rewards. So let's make this more personal. I have half my time already, but this future of experiential medicine for me began 17 years ago. So back in 2008, I was at University of California, where I still am, have my own lab called Gazzaley Lab at the time. That has changed now. And we came up with a game called NeuroRacer that challenges attention and cognitive control systems at a very high level. I teamed up with friends of mine at LucasArts. We built this game. We did 5 years of research, and we published it in 2013. So pretty much the last time I was on stage here. It was a cover of Nature paper, which is as good as it gets for us scientists. And what we showed here is that the older adults that played this game for a month showed their improvement on the game, but also the transfer of benefits to improved attention and working memory outside of the game, as well as sustainability of effects, and even looking at neural activity that correlates with these benefits. Now we're going to fast forward again to the formation of a company that occurred pretty much around the time I was here on stage. And what we've done is we took a high-level approach to game development, art, music, story, usability, same underlying mechanics, that same engine of that video game, and advanced it through multiple clinical trials. Now I know when I was here in 2014, I told this audience that one day this game will reach the highest pinnacle of medical device, which is approval. And now, fortunately, I'm able to say that we have done that. We are now the first and still only FDA-approved video game for a clinical condition. So thank you very. There was a long time I thought that I was going to have to take those words back at some point, but we got there. There are now 3 FDA approvals for this game. It is for the treatment of ADHD in children 8 to 12, and then another approval took it through adolescents. And then recently approval as an over-the-counter. So those are prescription treatments. That's an RX de novo approval as a class 2 medical device. We now also have approval as an over-the-counter based on another study for adults with ADHD. And most recently, a month ago, the Japanese PMDA, which is their FDA version, approved this game based on 2 clinical trials in Japan for treatment of children in Japan, 8 to 12-year-olds with ADHD. So super excited. What that really does is starts breaking down this false view that there's something culturally selective about this game for people from the US, and really starts opening up the global potential of this and other type of digital treatments. So lots to say there, but that's the Achilles story. Now, I told you my lab had transformed. After our Nature paper, we became a research center called Neuroscape. You're taking a look at some of our labs here. And over the last decade, we've been expanding this view of closed loop digital interactions as medicine. We have more than I could talk about. It would take an hour to sort of go through all of these. We have 10 different games, but you see a lot of them are sort of in the immersive domain, from spatial navigation to rhythm to physical fitness training, and they've been published over the last several years showing benefits also in attention, but in perceptual decision-making, in memory, and other domains, in both children and older adults, sustainability of effects, neural mechanisms, all of that is described in these papers. We also reached back to the most ancient experiential medicine. Meditation, mindfulness have numerous studies. Some are targeted more for children, others on adults. We have a paper that's coming out soon showing that in seniors, our 6 weeks of our meditation-based game that we built with a real leader in the field, Jack Kornfield, improves not just attention, but also stress responsivity in seniors and actually telomere length shortening. So really exciting to show that degree of transfer to cellular markers of aging from playing an interactive closed-loop experience that uses mindfulness mechanics. All right. We are also very interested in more passive experiences. Our games are exhausting. You know, with that closed loop system in place, it's constantly pushing you to the edge of your abilities. I'm interested in what people that don't like that type of engagement or are not capable of it might get benefits from more passive experiences. Here the focus is on nature and music. You could see some of it displayed here. That's my little girl who's sitting in the back, Evie. I told you I'd give you a shout out. So there's my 4-year-old who is experiencing this nature journey. And what you do here is, this is a one-person laboratory. So what we bring together here is multi-sensory immersion. You see, hear, smell, and feel nature music journeys over the course of an hour. Well, we bring on multimodal biosensing. So over 160 electrodes of data is being captured across your brain and your body to help understand the states of arousal, valence, and attention, how they're deployed over time, and how we might develop physiological signatures of things like awe and wonder and joy, and then show how these could translate to wellness benefits. So this is a hugely ambitious, sort of crazy study, but one I'm really excited about because it brings together all the elements that I've been talking about today. All right, so I'm giving you full Daniel Kraft New York style talk today, but I did want to get through a lot, so hopefully that made sense. I'm going to slow it down for the next med part of this talk. So that was really just to catch you up on where we are right now. And now I want to use the rest of my time to unpack a little bit about where we're going. So we talked about closed loop experiences. We showed how it can be delivered in interactive, sort of challenging ways and also passive ways. And now where do we go next? What is the future? So one is really taking diagnostics to the next level. This is one of the tools we created that's really been positioned and delivered more as entertainment at this point and education. But this is My Glass Brain. If you haven't seen it before, it's a combination of an MRI image with EEG with multiple processing, including Fourier transformation, artifact rejection, source localization, multivariate Granger causality, looking at the communication between different brain areas, all occurring in real time while I'm playing one of our games. Can we bring this real-time visualization of neural activity, now we're looking at something called glass body, into the gaming experience, so that sort of the next level of neurofeedback and biofeedback, to be able to see your own signals and bring them into game environments. And where do we bring these closed loop experiences? Well, one way is that we could not just, like for example, Endeavor right now really works. The input to the closed loop is the accelerometer and the tap screen. Can we bring neural data directly into gameplay to get more, core information about how your brain is really working? We have a paper showing that that's possible, that we could increase the outcomes with neural data on top of behavioral data. And we have 2 papers showing that we could bring physiological data like heart rate into gameplay. That's in our physical fitness game called Body Brain Trainer. So there's an immense amount of work to do there. I'm going to tell you the future in just a moment of where we're heading with that. The other thing I want to mention is that these games and these interactive experiences or passive experiences activate brain networks, but we think we can enhance on top of that. So we have a big research program to use non-invasive brain stimulation. We started with TMS, and then we use direct current. Now we mostly use alternating current stimulation delivered transcranially to see if we can boost the effects that we get from being in and engaging in a closed-loop video game. These are some of the work that we've been doing in that domain. The real idea is closed loop, right? So that we can tailor the oscillations and the frequencies that we are stimulating at based upon your own brain in the moment. This is a very tricky engineering feat, but it is the direction that we're heading. All right, so where does that nature journey study go? So we're collecting a lot of data there, but the real mission, the sort of 10-year mission, hopefully we'll get closer in 5 years, is to take that multimodal biosensing data. So we have 160 electrodes capturing aspects of your state, bring that into a closed loop system with a multi-sensory immersive environment. So this is the direction we're heading, and this is where AI comes into this. You didn't think I was going to get through this whole talk without an AI mention. So the first AI is sort of the classic, yesterday's AI, that's still quite present today, which is machine learning, pattern classification, what I'm referring to here as interpretive AI. How does all of this four-dimensional data, you have all of these different signals moving through time, how do they really tell us something meaningful in real time about someone's state? And then, right now, how we generate our closed-loop experiences is essentially we have an asset library that an algorithm says, oh, you're going fast, I'm going to pick out a slow stimulus, you got red, I'm going to give you something a little closer to orange. That's how these video games adjust. But I do think there's potential for generative AI here. So you can imagine a prompt not being a text prompt, but being a full multimodal physiological prompt, picking up signals about your state that you might not even be aware of, or you may not be able to communicate about, and feeding that into a generative system, not to create a text response or a video or a picture or video, but a full immersive experience that's challenging and rewarding you in the perfect way to help your brain, to help optimize it, to nurture it, to even act preventatively and start decreasing the chance of developing and worsening ADHD and depression into suicide. Eventually, I think what we have here is what I am thinking about as a closed-loop AI system, where the very sort of fine-tuning expert model that might be working on a foundation model is being adapted and adjusted in real time. The very data that you're feeding into it is changing due to the experience. So I think this is a really exciting merging of the work that we're doing with AI in lots of different ways. This is the very beginning. If anyone's interested in this, has skills in this, investment in this, please let me know. But this is the direction that we are heading. So just to put this all together, still got 19 seconds here. This is what I think the future of experiential medicine will be, right? We have multimodal biosensing integrated with high-level art, music, story, and game mechanics delivered in multi-sensory immersive environments. Lots to do there. But it doesn't mean that pills or molecules are bad, right? Technology is not good or bad, right? Fire burns your house down, cooks your dinner. Nuclear, reactions could be energy. They could be bombs. Video games could be completely debilitating to people's lives because that's all you do, or they could be medicine. Same way with molecules, right? In small dose, they're medicine. In large dose, they're poison. I think that there'll be a day that we look back on how we're using our molecular medicines in the way we look back on surgery. You heard some of these and thinking, that was just barbaric. Like, I cannot believe we give those doses to children. And so what I hope is that when we think about the integration of molecular medicine and experiential medicine, we'll be able to have better effects by integrating them and can lower those doses. Don't think of them as a silo, which we often do now, but think of them as part of a system where we use the experience to activate the network selectively. We have not ever accomplished that with a drug before. And then use these neurotransmitter receptor agonists and all these interesting tools we have as an activator to give that extra edge. There's hardly any research in that. Where we're heading, our first study is on looking at the interaction between molecules and experience is with this particular molecule. So we have several psychedelic research studies that we already started at Neuroscape. I view these as molecularly initiated experiential medicines. How do we create context using digital experiences, the art, the music, the story, built on real-time information about what's happening with a person to create safer, more effective trips as treatments for the clinical conditions that they're already showing value in without even all of those details. So this is how we hope to bring that all together. So I just want to go back to this. I usually don't close with the slide I started with, but man, it is some crazy times right now, and I really feel that we have to acknowledge the fact that our minds, and there have been times in history where we have prioritized development of the human mind, and I'd say this is just not one of those times. And so this is not the only solution, but we do have to think, especially about all the amazing technologies we have that often have diminished us. How do we intentionally target them to enhance us as humans? And we can do this, and we absolutely need to do this. So with that, I'd like to thank you for your attention today.
Hello, everyone. It's a great pleasure to be with you here today. Let's just take a moment and acknowledge what extraordinary times we're living in. Over the last decade, we have witnessed an explosion in both the diversity and accessibility of information technology. And right now, we are standing on the verge of a phase shift with the emergence of consumer-level virtual reality, augmented reality, motion capture, wearable physiological devices, and artificial intelligence. And I think it is clear that our information revolution has had a very positive impact on our lives. However, we know that there are consequences in the way that we interact with each other, our environment, and ourselves. And this could range broadly from mild inconveniences to undeniable impacts on our safety. So what is going on here? What is going on in here, right? So for that, we turn to neuroscience, where my colleagues and I have been studying the underlying abilities of our brain that enable us to interact dynamically with this complex world we live in. We call this cognitive control, and it consists of a triad of attention, our ability to direct our limited cognitive resources in space and time at the focus of our goals, working memory, holding and manipulating that information in mind when it is no longer present in our environment, and goal management, our ability to fluidly move between multiple goals. Now, as impressive as these abilities are, we're now aware that they have very fundamental limitations. In many ways, they have not evolved very much from our primitive ancestors. We have the ability to fire our attention like an arrow, but not cast it out broadly, like throwing a net into the ocean. We have very restricted limitations on both the capacity and the fidelity that we could represent information in mind when it's not present around us. And with each switch between a task, we suffer a degradation in our performance. And we now know that we have a surprising inability to actually simultaneously multitask. And then along come our higher order goals, which are arguably the most defining feature of the human mind. And they collide headfirst with these underlying limitations to create interference, which then pervades every aspect of our lives. Now, it's really important to note here that technology did not create this conflict, but it certainly has aggravated it by offering us an unprecedented access to information. In many ways, we are ancient brains living in a modern world. My goal is to flip this story around, to use modern technology as a tool to improve our cognitive control abilities, to refine our behavior, and to elevate our minds. So how is that even possible? Well, sort of in a simple way, technology has the ability to create powerful experiences. And experiences are the gateway to brain plasticity, that wondrously complex dance of change that occurs in all of our brains all the time at every level, from its structure, its function, and its chemistry. We all know how powerful this relationship is between experience and brain plasticity. Even just witnessing a single tragic event can induce brain trauma that detrimentally affects the rest of a person's life, right? We call that PTSD. Our challenge now is how do we use modern technology to create experiences to maximally harness brain plasticity to better our lives? The most effective way we can do that is to create what is known as a closed-loop system. A closed-loop system is where you intervene in some way, and as rapidly as possible, you record the impact of that intervention. You then take that data, reapply it back to adjust the intervention, and then apply again, cycling over and over, refining and optimizing. This is the most powerful way to change anything, whether it's physical or biological. In my laboratory at UCSF, we create closed-loop systems between our brain and custom-designed video games that we create in the lab. This is how it works. While you're playing a game, we're recording every aspect of your performance that we have access to, and we feed that into the game engine. The game then feeds back an environment to you that's adaptively adjusted and scaled to your ability, so it's challenging you right at that level all the time, like a personal trainer pushing your brain every moment. We can also feed back rewards to you in real time, motivating you to be deeply immersed and engaged in that gameplay. We could bring on other new technology that I mentioned to you. For example, motion capture and your physiology that can give us a richer readout on your performance that we could then feed into the game engine. We can also now present richer environments through augmented and virtual reality that are closer to the real world. And then we can tie all of this together with artificial intelligence algorithms to create a truly integrated, multimodal closed-loop system. This is the most powerful way that I'm aware of to actually change the function of the brain. Let me make this a little less abstract. I'll tell you my first experience in this domain, which happened 7 years ago when I asked myself in my lab this question. Can we create a custom-designed video game using those closed-loop systems that I just described to you to enhance cognitive control abilities in older adults? So I have been studying for a long time all of these abilities, attention, working memory, and goal management, especially how they change as we get older. I'm not talking about things like dementia, Alzheimer's disease, the cause of dementia, but just healthy aging. And what we know is that they all decline with aging. And so I had a hypothesis. If we create a game to challenge the brain in one of these domains, for example, goal management, can we engender improvements in these other abilities? Because what we have learned is that they are all mechanistically related to each other through networks that involve the prefrontal cortex, the most evolved part of our brain, and the rest of our brain. So that's the hypothesis we had. In order to do that, we built a video game. I reached out to friends of mine that worked at LucasArts, and I asked if they would come down to the lab and help us develop a game that I had designed to challenge older adults in that goal management. So this is a multitasking video game that uses adaptivity and feedback in a closed-loop system. And just to give you a quick snapshot of some of the data, we were able to use that game in a diagnostic mode to show that multitasking declines from 20 years old to 80 years old. So it doesn't hold parallel and then plummet in one horrible year when you're 70. It actually plummets every single year. We had our older adults take home an adaptive version of the game on the laptop and play it for 12 hours, 1 hour a day, 3 days a week for 4 weeks. We brought them back a month later, and the first thing we found was that their ability to play the game and multitask on it exceeded the level of 20-year-olds who played it on a single visit. But most importantly was that we were able to confirm our hypothesis. We also showed that we were able to improve their attention and their working memory abilities, even though neither of those things were directly trained by gameplay. We were really fortunate that this was published in Nature magazine as the cover at the end of 2013. And as excited as I am, this was a 5-year project that we did, and we had a massive team involved. So I don't want to diminish it, but the bigger message here is that you can work as a group of scientists closely with video game professionals that know how to build these things at a very high level, target it to a known deficit in a population, and then do a carefully controlled study with neural markers to look for mechanism. This is what we have to do if we're going to create a whole new class of interventions to improve how the brain functions. We have to treat it at this level, both on the development side and on the validation side. What's happening now is that we've been working with a company that I co-founded to help move this game out of the laboratory into the real world. We now have a game that's much more fun. If you're not going to bring violence into a video game and you want young people to play it, you have to work very challenging on that. So we bring in art, music, and story, and we also have refined those closed-loop mechanics. This game, however, much to many people's dismay, is not available right now in the iTunes Store. It's not a consumer game. There are multiple clinical trials going on right now, including a big one that's starting to try to seek FDA approval as this game as a therapeutic intervention for ADHD. So potentially, we're looking at prescribable video games within the next year. You're going to go to your doctor's office, pad comes out, not a drug, 2 months of iPad. And what I hope we'll see is really a whole new class, a whole new category of digital medicine. And so that's one really exciting option. But we can go further. Video games are so exciting to us because they activate brain networks in a selective way, something that we have never successfully done with a small molecule. And then we could use the closed-loop mechanics that I showed you about to drive improvement of that system. But that's just the beginning. Neuroscience could take us much further. And we are studying in our lab new approaches to what we call neuromodulation and neurofeedback. In order to do this, we had to create a new technology that we're working on in large collaborations. We call it the glass brain. What you're looking at here is a combination of MRI and EEG, where we're recording in real time what's going on in someone's brain while they're playing one of our video games. Each of these colors correspond to a different frequency and rhythm in the brain that we're capturing. And we're also looking at how information is traveling between areas. So this is a large endeavor. We've also been able to take this information and bring it into our game engine so that someone can actually hold a joystick and navigate their own brain while they play. Very surreal. Trust me. we think that there's great diagnostic potential here to look at how someone's brain is activating while we're challenging them in a very specific way. But what I'm most excited about is fully closing that loop that we talked about. So let me just pull this all together and describe what I mean by that. It's 2015. And if you go to a doctor's office with a trouble with your attention abilities, whether you're 12 or 80 years old, you're likely going to get one of these. And this is going to do this, right? So we know that we don't have the ability to carefully target small molecules to neural networks, which are the underlying computational unit of the brain, right? They act more globally at the level of neurotransmitters. Because of that, we have to bring our doses to very high levels to get effects, and then we wind up getting pretty much just the same amount of side effects. We hope that even by the year 2020, we'll be able to reduce doses, maybe sometimes removing drugs completely from this scenario, to decrease those side effects, and then use apps that we're now developing to carefully understand where are the weaknesses in how your brain is processing information, to guide video games that then activate those networks selectively and use those closed-loop algorithms to drive improvement. We could then use the glass brain to feed neural data directly into the game engine and feed back an environment that is now targeting those weaknesses selectively in how you process. So we think of it as a surgical approach, like a gamma knife, where we point the game engine at just those parts of how your brain is processing information that needs the most optimization. We're also studying taking this neural data and using it to guide the stimulation parameters for electrical stimulation of the brain. We have recently learned that you can stimulate the brain electrically, either with direct current or alternating current that actually matches the rhythms inside of the brain, and this can be used to increase the brain plasticity. We're starting to show that you can actually enhance the learning curve during gameplay if you stimulate it in this way. So what we're looking at here as this all comes together is an approach that's targeted, it's personalized, not just to the individual, but to how that person changes over time. It changes with them. It's multimodal, right? It's not stepping in the footsteps of the past mistakes that we've made in building out these systems in a very siloed way. The brain is way too complicated to improve with one single modality. It's not going to be a holy grail. So here we have an interaction of many different systems, and we have multiple closed loops that are interacting together. One of the most exciting things about this is because this technology is accessible, right? We could use cloud-based analytics and server-side support, and many of these things are already consumer-grade products. We can do this in the real world and real time. That's something we don't do right now, right? Months could pass between when you go into a doctor's office and when you come back and have an adjustment of a medication. So this really changes that dynamic relationship. Over the next 10 years, we will be advancing this technology through studies in multiple neurological and psychiatric conditions to see how it can be used to improve brain function. And this is not a wish list. All of these conversations have begun already. In parallel to that, we will be exploring the application of this approach to healthy minds as new educational and wellness tools to improve cognition and advance the health and wellness of all of us. Thank you for your attention.
Thank you for all being here. Thank you for that amazing introduction. I'm excited. This is going to be brief talks. Both of us are giving brief talks so we could dive into questions. It's a lot more fun and I think interesting to interact. But I do want to present at least a high level of the work I've been doing to use neuroscience and technology to improve our lives. I have a lot of positive messages, but I like to begin these talks sort of grounded with a maybe a little bit of a harder view on our current times. And I would say that I've come to believe that our species, our entire species around the world, is in the midst of a crisis. And not just an external crisis that we know we've inflicted on our planet, but an internal crisis, a crisis of our minds, what I call a cognition crisis. So what is a cognition crisis? I would say when it comes to both understanding and enhancing human cognition, we are tragically lacking. And I'm defining that very broadly here. Our attention, memory, perception, reasoning, and decision-making, our imagination and creativity, how we regulate our emotions, how we feel empathy and compassion.
There have been times in human history where societies have prioritized improving these capacities of the mind. And I'd say that now is just generally not one of those times. And we're paying a great price for this. So over 500 million people are suffering debilitating effects of impairment in cognition. And it's getting worse, notably for our children and teens, as I know everyone here is familiar with, from depression, anxiety, ADHD, attention deficits, and in our seniors for memory and dementia. But I would say, people would think of that as a mental health crisis. I say it is bigger than that. This is a crisis that touches us all. Because if you think about the limitations we have in long-term decision-making and analytical thinking and empathic concern, you could just, read the news every day to see our limitations in those domains. So we have a challenge here in front of us. But today, when it comes to mental health in the medical domain, the paradigm is that there is a pill out there to cure our ailing brains. We haven't found it, but we will find it. We just have to keep looking. And we've been doing this for 70 years. Now, there's nothing conceptually wrong with the idea of a molecule to improve cognition. And it has helped many individuals, but it's just not served us well overall. So while we see a decrease in suffering and death from infectious disease and cardiac disease and even cancer, we see the reverse trend occurring for afflictions of the mind: anxiety, depression, memory impairment, suicide. And so I would say we need a new paradigm and we need a new medicine. And what I want to talk to you today is a proposal that a solution exists by harnessing a core aspect of human growth and development, which is experience. So for thousands of years, we humans have been creating and ritualizing experiences to improve the quality of our lives: music, art, dance, stories, sports, and games. We've even intentionally developed experiences that were targeted to improve our mental health, right? A central tenet of the ancient widespread practices of meditation and mindfulness are release of suffering from unhealthy states: stress, fear, grief, craving, and clinging. Also, experience is the driving force, the main driving force besides injury, of our brain's plasticity, the capacity of our brain to modify itself at every level: its structure, its chemistry, and its function. So despite this history of experience as medicine, and despite the grounding in neuroscience, most people don't think about experience as medicine in the same way they would think about a pill. And what I want to propose to you, that there is an opportunity to shift that by using technologies to create experiences. So we are in a unique time of experiential technologies. So you're all holding them, right? These are experiential technologies: your phone, your tablets, soon your watches to some degree. But there is a phase shift happening with the commercialization now of augmented reality, virtual reality, motion capture devices, wearable physiological devices, and of course, AI. So as you appreciate, most of this technology is being targeted for communication and entertainment. But I believe that there is a capacity for these technologies, as well as the ones you have now, to enhance us as humans and not diminish us, as they often do. And that pathway involves intentional, careful development of experiential technologies that can deliver these experiences both in a personalized and targeted way. How do we do that? I would propose that we do that through a type of experience that I call the closed-loop experience. A closed-loop experience is one in which the environment that you're presented with from your devices is updated in real time based upon your own data. So let's break that down. So here's your brain on this side interacting with a digital technology. While that's occurring, sensors, cameras are recording aspects of your state, your stress, your emotions, aspects of your cognition captured in your performance, and that is fed into a processor, which is then, usually using just adaptive algorithms, is feeding back an environment to you that's personalized in terms of the sensations, the challenges, and rewards. This is a very powerful circuit that can then be optimized with advances in machine learning and AI. And I'm going to come back to that and give some details. Two things I want to note here. It is the mechanics, the nature of the experience that activates brain networks selectively. We have never accomplished that in any other way with a drug or any other type of brain stimulation. It is that selectivity that allows us to apply treatments with lower side effects, which we do not get with blunt instruments like the drugs we use. And it is the adaptive nature of this closed loop experience that is putting pressure on those underlying networks and harnessing the brain's inherent plasticity to improve its own function. So it is this aspect of both the interactivity as well as the adaptivity that leads to the power of this type of experience. So I just want to give you one example, one that I've been working on for 16 years now, of how you can take a closed-loop design, modern technology, and a basis in neuroscience, and create, validate, and then implement these as digital health solutions. So in 2008, I was working in my lab in San Francisco and came up with the idea of building a video game as a closed-loop experience to improve attention abilities. And the design was based on my work. And why a video game? You could have many types of closed-loop experiences. It doesn't have to be a game. But games are a unique type of experience, and fun is important to human beings. Both the engagement, depth of engagement in the moment, as well as our compliance and sustainability to return to it. So we built this game with professionals in the industry, friends of mine at LucasArts, a big video game company at the time. And then we spent years studying this game in healthy older adults. Published this in Nature in 2013, cover of Nature, good moment for us scientists. And what we showed here is that older adults that played this game for 1 month didn't just improve their ability to play the game, we also improved their attention and their short-term memory for faces, which is very different than gameplay, on tests outside of the game. And this was a well-controlled study that really, it's a small study, but an important first one because it really served as a blueprint for how we might work together, scientists and professionals in another industry, like the video game industry, to build something unique and then do a well-designed randomized controlled trial to understand its benefits. So long story fast, this led to me to start a company. I still kept my position as a professor at the university, but started a company called Achille. We designed a much better version of this game. Same engine, same mechanics of the game, but higher levels of art, music, story, all the things you need to do to deliver it to people, to inspire and them to engage in it deeply. And then after many years of research, this game in 2020 and 2022 was approved by the FDA, the US FDA, as a medical device for the treatment of children with ADHD. So it was a long run there to get this approval. It is still the only video game ever approved by the FDA for a medical condition. There are now 3 approvals, one for children, 8 to 12-year-olds with ADHD, then based on new data, adolescents with ADHD, and now just a month and a half ago, approval for adults with ADHD based upon data that showed 7 times the benefit on attention in adults compared to children by playing this game. And that is actually an over-the-counter treatment that doesn't require prescription. So there's a lot to talk about there, but we now have tens of thousands of games that have been prescribed by doctors in every state in the US to treat children as an alternative, or sometimes side by side with stimulants. So this has been a really exciting journey, and what I want to do in the rest of my time is just tell you what we're working on that a lot of people don't know about, and then where we're going into the future. So I'm going to go quickly through this. But the goal is to validate it across numerous conditions, including people that are healthy, to go back to the beginning of my talk, as essentially wellness tools to improve everyone's brain and minds. So in 2016, my lab got bigger after our Nature paper, and we became a research center called Neuroscape. You could see a picture here of several of our labs. They're not the standard neuroscience lab, but I can assure you we use functional imaging like MRI and high-density EEG to record data, but we do a lot of very advanced multimedia work as well. And we've been building a lot of different closed-loop video games. Here's an example of 5 of them, their names. They all involve levels of art, music, and story to challenge the brain in different ways. Sometimes they take place in virtual environments or tablets. Sometimes the data that's going in is performance data, and other times it's neural data or heart rate data. And then we spend an extensive amount of time in figuring out the highest level of empirical experimental validation of these tools. So we do double-blind, randomized, placebo-controlled trials on video games, and we constantly are trying to advance our methodology. This is an example of what a participant in one of our studies might do before and then after a game compared to a control group to see changes across not just the brain, but many systems around the body, including cellular markers of aging telomeres, where we've recently showed some changes. A lot of our games are focused in the meditation and mindfulness domain. There is extensive history of benefits from these approaches. As I said, these are the oldest experiential medicines. If anything, we are just a modification, a way of delivering it using digital technologies more accessibly, more reproducibly, and more testably. But a lot of the principles are already there. We have 3 randomized controlled trials that we did with our game Metatrain. One on healthy young adults, one on children with adverse life events and attention deficits. That was actually done in India. And then a study on healthy older adults. All of them shows that just 6 weeks of playing this closed-loop meditative video game. So we take principles of concentrative meditation, breath-focused meditation, and combine them with adaptive rewards and feedback. And we showed in these 3 studies, in all of them, regardless of the population, we improve attention abilities. And in seniors, we improve attention, responsivity to stress, as well as lengthening telomeres, so a cellular marker of aging, just with 6 weeks of gameplay at home. And we have games to study children who have trouble focusing on their breath called Engage. I'm not going to get into the details of these. And we're also interested, can we use these mechanics and this gameplay to improve things like empathy and compassion, which I think the world so desperately needs more of right now. We do a lot with virtual reality, essentially head-mounted displays. Here's 2 of our games using head-mount displays and 1 that's using full-body motion capture. These are all the publications just over the last several years with these games. Labyrinth is a navigation game in a 3D world that has been shown to improve memory in older adults, and we're studying that in mild cognitive impairment and early Alzheimer's disease as a treatment right now. Coherence is a rhythm game. Rhythm is fundamental to everything we do, to how our brain works, how we anticipate stimuli in our environment. And we've now shown that playing Coherence by older adults improves their memory for faces, which is completely different than the gameplay. And in children, improves their attention and their reading fluency. So rhythm is pretty much connected with everything we do. Body Brain Trainer unites cognitive and physical challenges because they both have been shown to have improvements in cognition. And here we show that we can improve attention abilities and physical fitness metrics in both children and older adults after 2 months of play, and then that persists 1 year later. Both of these papers show that finding. So now I want to tell you that the one challenge of many of these games is that they are challenging. They are exhausting, they are frustrating. There's a lot of thrown tablets out there from kids playing our games. And so I was very interested in games that have a more passive interaction. As you're probably familiar with, there is a literature that exists that shows exposure to nature is not just fun, but is restorative. It could have benefits on stress and mood and anxiety and sleep. And so what we've worked on is a digitally delivered nature experience to see if we could have benefits without the intense interaction that we have in many of our games. In order to accomplish this, we built what you see over there. This was a COVID project of mine, building a sensory immersion lab. So when you go through this journey that we worked on with artists and musicians, you see, hear, smell, and feel these nature environments. And so while you go through this journey, this passive journey, only interrupting your experience just to press a button if you're feeling awe or wonder or hope or calmness, and then we could break down what those mean by recording what we call multimodal biosensing. So this is, I believe, the most comprehensive biometric system that humans have ever gone through. It takes around 45 minutes to apply 170 electrodes. It's not just the brain that we're sampling with high density, but all across the body, from heart rate, facial expression, electrodermal activity, which is sweat responses, and even looking at contractility of the heart and the gut. So all of this, as you can imagine, is quite interesting. It's based on the hypothesis that we're never going to learn everything about our state, our arousal, our emotions, and our attention by one modality alone. And this is an incredible machine learning and AI challenge just to understand all this information. So I'm going to conclude by telling you what we're working on now. So a lot of that is already out there, but where do we go with what is the latest in technology in terms of multimodal recording and sensory immersion? So I'll conclude with this sort of vision of the future, although this is actually what we are working on in San Francisco right now. You can imagine a closed loop where it's not just your performance data or your heart rate or brain data, but all of the data being funneled in, so multimodal biosensing contributing to a closed loop, adaptive, personalized, multi-sensory environment. This is the direction we're heading in. One of the big challenges, there is so much data and these environments are so complex, it's very hard to adapt them based on any of the staircase algorithms and the technology that we've already used. So this is an incredible opportunity for AI, both machine learning, what we call pattern classification, or interpretive AI, to make sense of all that data in real time, or very close to real time. Then there's an opportunity for generative AI to create these immersive environments, not with like a text prompt into a chat GPT or some output of that way, but using your own physiology, even without your awareness, to guide the environment that you're in. So I think this will really be the future of mental health tools to help improve across the range of cognitive impairments that I described. So to conclude, we bring together closed-loop designs, often inspired by real-world events like meditation, mindfulness, rhythm, dance, couple it with multimodal biosensing and sensory immersive environments. And then we could go back to the idea that a molecule might have value. Instead of using a pill in a silo where we have to increase the doses to such high levels to get the effects we want, we get just as many side effects, perhaps we could use 1/10 of the dose just to activate these neurotransmitter systems without the specificity, and then use these experiential treatments to have the selective activation. So I believe that we will be looking at this as a future medicine across a range of conditions and hopefully around the world. So with that, I'd like to thank you for your attention.